Hello everybody, this is the presentation for week 9 on sampling and research. We are going to be looking at the materials from chapter 8 of our text, and I'm going to be illustrating for you the prominent concepts and talking a little bit about each one as we go along. This particular presentation corresponds with the questions that come on your participation sheet for this week. So you'll notice that a lot of the questions will appear at the top of the slides, and they will again resemble those from your sheets. Okay, without further ado, we'll keep going. Okay, the first thing that we want to ask ourselves today is, why do we perform sampling and research? Well, there's some very practical reasons why, and our book notes a couple of them, but I think most of you can probably figure them out just implicitly and through inference. It would be a near impossibility to talk to each and every person who is representative of a population you wish to study. For example, even when we're talking about the homeless count in Sacramento, which has largely been done through Professor Biaki's efforts from our very own social work department, the prospect of us reaching out to each and every single individual who is homeless in the Sacramento area is truly impossible. We do not have the time or the money or the hours for people, volunteers, to be able to reach every single person. Not even when the federal government does its census each 10 years rather, do the census takers reach every single person in the United States. It just doesn't happen. So in fact, even the census is a bit of a sampling effort. So we don't have all the time, we don't have all the money, and apparently neither does the federal government, to do sampling for each and every single person of any category. So we have to rely on samples instead. You can see from our picture here what a sample looks like. We have a larger population, and we take people from that population to try to best represent the larger population through the sample. In other words, we're trying to learn about a larger population by taking a sample of it. That's basically what sampling is all about, or as our text states, selecting participants for a study is effectively what we're talking about here. So now I've given you a couple of reasons why we do sampling, why it's not possible to even go through the process of getting everybody from a population. Sampling has to be the way we do it, and even sampling takes time and money in a lot of cases. So that's why we do perform sampling in research. Now I'd like to talk a little bit about what a representative sample is and why it's important. A representative sample is one that has a pretty clear connection between the sample itself and the population you're studying. Take a look at the slide on the left, please. If you notice, there are 5 rows of people, and in each row there are different groups within each. And you'll notice that below you'll see that there are samples A, B, and C taken. Notice that in terms of the mix of people, only C tends to represent proportionally what the population actually is. Okay? Otherwise, for example, you're missing groups of people in sample A, same thing with B. Only C really captures a full diverse perspective and cross-cutting of the population itself. In research, we try our best to make our sampling efforts resemble the population at hand. One way we do this in terms of practical measures is we select a target population, we find a number of people that we call for our sample called the sampling frame. Each individual within the sampling frame will be known as an element. Okay. So then when we have a sampling frame, we have different ways, which we'll get to in a moment, of taking a sample from the sampling frame, okay, which comprises our sample. So again, there's quite a process here, but the goal is to have a representative sample, which is a sample that best represents in its composition the population which you are trying to study. So in the last slide, we talked about efforts to try to make our sample a representative sample of any population we're trying to study. As it turns out, and I mentioned this earlier, there's different ways to collect, if I can say it that way, participants for our samples. In other words, the process that we go about selecting our participants is very important with respect to how we can feel confident that we have a representative sample or not. Our book talks a lot about the two varieties of sampling methods, probability sampling and non-probability sampling. So when we're trying to figure out how to get a sample, we need to ask ourselves a couple of questions. How randomized do we need to make the sample, or does it matter? When it comes to probability sampling, this is the process by which you are going to randomly sample elements, or in this case, participants who would represent the elements from a sample frame. So let me go ahead and take a look at this. They almost look like Connect 4 if you played that game. Board games on the screen in front of you. On the left, we have an example of probability sampling. On the right, we have non-probability sampling. And the reason why these illustrations represent both of these are as such. Probability sampling is a randomized method for sampling elements from a sampling frame. Okay, and remember, a sample frame is a group from any population that you're going to draw your sample from. Okay, so each one of these boxes or Connect 4 boards is in fact a sampling frame. It includes all of the available elements that we would take our sample from. Now, every one of these little holes or spots right here, let's just pretend that they're spaces to fill on a Connect 4 board. Okay, there is an equal chance for all of these, and the percentage is known. The probability or the percentage is known. Okay, how much of a chance each one of these has for being selected. Okay, that's probability sample. Randomized, okay, where each element has the same known chance of being selected for any research endeavor. Okay, so the reason why we would select probability is if we're wanting to make sure that our sample has the highest probability of resembling the greater population. If you do things like we're going to talk about in a minute with non-probability, with a lot of the researcher involved selecting, you introduce a higher level of bias. There's more opportunity for bias on the part of the researcher or researchers when you are engaging in a non-randomized format of selecting participants. Probability sampling is largely what we use when our research endeavor is quantitative, right? We're trying to find a sample that resembles a population, and the method we're using, randomization, guarantees that we get a little bit closer to that because we're taking the researcher out of the question out of the process to the highest point possible. So with probability sampling, we leave it to chance who's going to be selected and who's not. With non-probability sampling, chance is not entered into the equation. We have the researcher or researchers selecting people. Now, there is in fact a time and a place for both of these, but it really depends on what you're trying to achieve with your research. If your research is largely geared toward trying to generalize to the larger population from the sample, you're probably going to want to use probability sampling. Why? It's more randomized, and it's going to, in terms of probability, make it a little more probable that you're going to have a representative sample than if you're selecting the participant yourself. Again, I stress that opens up the opportunity for a great deal more bias on the part of the researcher. Okay, so again, probability sampling, randomized. Okay, it's meant for research where we're trying to get the highest percentage of representativeness of the sample for the population. Okay, it matters whether or not it is generated randomly because again, we're trying to capture the most representative sample. Okay, we're trying to generalize, that's the language, we're trying to generalize from the sample to the population. Non-probability sampling, when would you use this? When we don't care about trying to generalize to a larger population. And when would that be? Well, when you're not trying to explain something, when you're not trying to show cause and effect. So again, when we're talking about non-probability sampling, this goes much more toward research that is qualitative in nature, where we're trying to describe and not explain something, okay? So when you're engaging in non-probability sampling, and we'll go over some of the varieties of that in a minute about what that looks like, what you're really doing is you are actively selecting specific participants or elements for your research on purpose. You are purposely doing this for a reason, and perhaps it's to get information-rich individuals or groups or families or whoever the unit of analysis is. So again, probability sampling is much more toward quantitative, non-probability sampling, much more toward qualitative research designs. Probability sampling, generalized, we're trying to generalize from a sample to the general or to the larger population. We get a more representative sample through randomized selection. Non-probability doesn't matter. It doesn't matter. We're not trying to generalize to a larger population. Okay, so these are all the things that our book talks about, and these are all the things I'm talking about now. But these illustrations you have right now, along with the explanations I gave you just now, are how you can distinguish probability and non-probability sampling methods. So now we're going to talk about the varieties of probability sampling. We already talked about what probability sampling is in the last slide. But now we're going to talk about what probability sampling, or I'm sorry, how probability sampling is executed, and maybe give some examples of how these different probability methods are defined. Okay, so let's take a look at this. In our book, we talk about simple random sampling, and that's represented by this picture right here. If you can imagine that this is our sampling frame, okay, and we put everyone in here's number in a hat. We have them, I don't know, let's see, draw numbers. And then we have corresponding numbers in a hat or a box, or it could be like on the lottery where they have those little ping pong balls floating around in an aired container. Okay, so either way, okay, random sampling is where you have a sampling frame and each one of the elements receives some kind of identification, and you simply are drawing randomly from whatever the means is, whatever the whatever method is, whether it's the numbers in a hat or the air, the ping pong balls floating around. This is the process where everyone has a number and you're pulling up some identifier that selects each one randomly from the sample. This is one of the more basic ways of doing this. Okay. Ultimately, when you have your sample, all of your elements that have been selected comprise the sample, and that would make it randomized. So again, randomized sampling is what we use in probability sampling. It's most connected to quantitative approach to science because, again, we're trying to get a representative sample that most resembles the population, so we can generalize what's going on in the sample is also likely what's happening with the population. Okay, let's move on to the next one, systematic sampling. So this is an example of a systematic sample, and this is where you have maybe a sheet of people whose names are on it, and you take every 10th person or every 5th person. In this particular case, it seems like we're skipping two, and then we're drawing the next person. Okay, so again, this is systematic sampling. Okay, it's another way that researchers use to randomly select from a sampling frame the elements or participants for the sample they're going to use. Okay, but again, the process is very randomized, even if it is systematic. Okay. The important thing is we're taking the researcher out of the process as much. We're leaving it more to chance than we are to anyone's specific bias. Okay, so now let's take a look at what we mean by stratified samples. Our book talks about this quite a bit too. Stratified samples, and actually they have a pretty good description of it on page 143 on our books. And again, it's when you know there's a certain percentage of people or a certain type of characteristic in the population, and you want it equally represented in your sample. So you intentionally, randomly sample from a specific population. And I know that sounds a bit contradictory, but on page 143, the point is made near the bottom with a illustration that if you know that 10% of your overall population is Native American, then you also want to make sure that 10% of your sample is Native American. And likewise, if you had 40% Latinos, Latinas, Latinx, okay, you would also want to make sure that of those who you sample, 40% are also of that population as well. So again, we are trying to get our sample in that particular case, although randomly, okay, to represent, a specific portion of the population so that it again mirrors the population, so that again, that the sample resembles the greater population. So again, let's say we have here that, 1 in 3 people are in our population African American. We want to make sure that at least 33% of our sample is African American. Okay, same thing with other groups. We would just want to make sure that the breakdown of the sample in terms of a stratified percentage represents the stratified percentages of the population. Okay, so 10% of African Americans at the greater population level, you want to make sure your sample includes 10% African American as well. Okay, cluster samples. This one can be a little trickier, but our book again does a pretty good job of illustrating what we mean by this. If you have clusters, you're taking clusters from a larger unit. And the way that they did it in our book was schools from school districts. Cluster sampling is often hold on a second here. It's often done in social work research because again, it can be difficult to get a sampling frame. And yet you're still trying to use a form of probability sampling. So again, you're taking a cluster. It's a random sample of a larger unit is taken. So if you had school districts, okay, for example, in our book, if you have a school district full of schools, okay, the school district will be your random. It would be your sampling frame. And so selecting schools from that school district, okay, again, it's clustered. You have clusters of schools. In the example in our book of the cluster of schools, we got numbers 4, 3, 7, and 9. Okay, again, we're still using random sampling, okay, but we're not breaking it down into the units like we did before. Okay, we're doing things in clusters rather than individual units. It's not the same thing. Okay, so again, it still has an element of randomness to it, but it's not purely random from the standpoint that we're selecting individuals. In this case, we're selecting clusters, again, in an attempt to be as random as possible. Okay. And now finally, we have non-probability sampling examples. How are they defined? What are examples of each? We're going to go through these really quickly. Each one of these is addressed in the book as well, beginning on page 146. On the far left top corner here, we have what we call typical cases or typical case sampling. This is where you have known specific groups and you are intentionally picking a person who represents a group. Our book talks about folks who qualify for maybe an after-school program as representing an entire class of people. What does this mean? It means that the researcher is actively in the process of selecting somebody who represents, or it could be, it doesn't have to be a person, it could be like a family, or it could be a group that represents a larger group or a larger population of people. But the key here is that the researcher is doing it on purpose, intentionally, without any acts of randomness inserted. So again, you can see how in this illustration, they're doing this by colors. Okay, 3, 5, and 9 represent some kind of a population. 1, 10, and 12 do as well. And you can see that 2, 4, 6, 7, 8, and 11 also represent. There's one, or in this case, two people from, well, 1 or 2 people from each one of these populations that is representing a typical case. Okay, that's how this is supposed to look. The key here is that it is being done decidedly. It is being done intentionally by the researcher. There is no act of random assignment. Okay, you're going to see that as the trend here, because that really is the definition of non-probability sampling. Let's take a look at this next one. This is what we can look at when we're talking about specific population members that have a criteria in them, and we're trying to identify those who fit into the criteria for our sample. So, for example, our book is using, for example, all of the folks in an agency that qualify for a certain benefit. If you were looking at a roster of all of the people in an agency who, for example, qualify for, let's say, food aid, okay, just that criterion alone, eligibility for food aid, okay, would be the criterion, and you would be using that to select, again, non-randomly but intentionally, people who fit that description, okay, for your sample. All right. Getting away from that a little bit, we have the snowball sampling. You can see how this works. It's where you see the researcher purposely selects somebody for a sample. That person goes and selects other people who then again select others. You can see how this works. It's snowballing. Each one reaches one. Okay, each one gets another person to participate. That is again not random, but instead intentional, which is again the touchstone of non-probability sampling. Coming down to the bottom row now, we can see in the far left, this looks an awful lot like the stratified random sampling. And for the most part, they look exactly like each other, except for the mechanism of collecting the participants. With the stratified random sampling, you truly were using randomness, or you're using probability to select the participants. In this particular case, the researcher is looking for the percentage of the participants of the quota. So again, what's left out here is the randomness. Otherwise, it's just an intentional act of looking for people who fit a certain quota, okay, of specific characteristics. So again, what's the difference between stratified and quota sampling? Well, one is a probability sampling, which is the stratified. The other is non-probability, and of course, by definition, okay, one of them is going to involve randomness. That's your probability / stratified. Okay, in this particular case, quota sampling is non-probability because the researcher is intentionally looking for people and finding them that fit this category. Okay, rather than drawing from a roster or a list of a lot of people who fit the category and then randomly choosing from that list. How about this one? Key informants. This is where you have somebody who's connected to a much larger population and being able to know a lot about a specific population. You can see here you have someone who's connected to a lot of different circles. Okay, this person in the middle might be a key informant. This person as well. Okay, there's people who are in fact connected to larger groups of people. They're information rich, as we call them. I think of, for example, folks in certain populations where they have a spiritual leader, or there's some kind of a representative in the community who speaks on behalf of larger communities. They're key informants. They're people who are connected in large ways to populations. And if you don't care about being random because you're not trying to generalize from a smaller population to a larger population. You're just trying to get descriptions. Well, then this is an actually a pretty ideal way to behave in terms of selecting people. How about convenience sampling? It's also called availability sampling. And you can see in this particular picture, the reason why I chose this picture is whoever's selecting in this case, they're picking the people who are closest to them. There's not an act of randomness here. This person is closest to these 5, so these 5 are the ones who are selected for the sample. This happens in agencies all the time. This is where, if we wanted to do research on people who are depressed, we don't do things randomly. We just simply take the people from our agency who are depressed because they're the closest to us. They're just, they're here. Here they are. So we just go with that. Sure, it looks an awful lot like the criterion sampling from above, but there's no act here. There's nothing other than proximity in this case as the determiner for who's getting in and who's staying out. It's who you have available to you, just like the title suggests. So what we've covered in this slide is all of the non-probability sampling methods that our book talks about, and hopefully did it in a way that made more sense because we're using visuals and pictures this time rather than simply just using words. I also tried to throw in some examples of how these work methodically. If you're watching a video of somebody doing one of these, I hope you have a clearer mind, a clearer picture in your mind of how it looks. So again, hopefully this was helpful and you were able to write down some notes on your participation sheet. We'll go over this when we meet in class on Thursday.